More likely than not, I'll give you a faulty code, and then you guys have to tell me what it's going to do. No, subroutines are not in this exam, which is both good and bad. The good thing is you don't have to deal with it this time. The bad thing is you have to deal with it next time. So it's good and bad. I'm not quite sure which way it is. But this one will be focusing on just arrays, indexing, taking the number of elements of something, and so on.
Is this on Wednesday?
This is next Wednesday, 1 week from today. So that means you should study as much as you can before next Monday so that you can ask questions on Monday. I will have to end the class earlier next Monday because there's a meeting I have to go to, that starts at 6:30. So I have to kind of end the class a little bit early next time. I'm not so sure about that. Yep, go ahead. Question? Yep, okay. So let me make sure I save this file. It's all online. It will be online, as soon as I upload the code. Are there any questions about the exam other than, the questions themselves? Yep. Tell you what, I can do this. Let me find out how to do that. Okay, that's the folder for today, and it doesn't have the. Can I compress it here? Nope, doesn't have an option to let me compress it. It's okay. I just have to run it separately. Zip-R 2010 1027. What I'm doing now is I'm uploading, what I have currently to the website, so this way I won't forget.
Okay. That way I'm not, emailing you at 11:30 at night.
Which is just when I start to work, so that's fine. That's not a problem.
I was going to say when I email you late nights when I get my best responses. Emailing you late at night when I get my best responses.
Yep, because I'm working. Okay, so I will label this as practice exam 2. I cannot spell. Answers. Upload the file to this folder. I know it's taking a little bit of time in the class, but this way I know for sure that I won't forget. It's working. Okay, so choose this, and we are done. So if you have a computer, for people with access to a computer right now, you can actually download a file right now and actually look at the solution files. I'm thinking that one of these days, if I have enough time, I can also change the screen recording part so it can upload to YouTube like live. So you only have a lag of like 15 minutes. After 15 minutes, you will get the stuff that I just talked about, which is close to TiVo, not quite. I always want to TiVo myself in the class because I cannot remember what I said about 30 seconds ago. So with a TiVo mechanism, it will be very helpful. All right. So if there are no questions about arrays and all the stuff that we have seen in the practice test, we are going back to talk about subroutines. Yep.
Just wanted to do another example that you asked.
Binary search? One thing you guys can do, which is not really hard, is to go to the algorithm for binary search and intentionally mess it up. instead of using m plus 1 to update b, use m. Okay, and then you can try to find an element and see what happens to it. So those would be good ways to kind of just to test it and see whether you can follow the algorithm when it is not correct, and also get to see the effect of the algorithm when it is incorrect. You can do it just for the b, just mess up b gets m plus 1, just forget the plus 1 part. You can also combine that with also messing up the e part. So e gets m, b gets m, and then you can see that it will get into an infinite loop if you're looking for a value that is not in the array. There's no way the two values can cross over once you get rid of the plus 1 and the minus 1 when you update b and e. So that would be a good test. The other thing you can do is to intentionally use an array that is not sorted. Okay? Use an array that is not sorted on regular binary search. Now, the binary search algorithm is already discussed. We have talked about it a few times. So don't modify the algorithm, but instead of starting out with an array that is already sorted, start with an array that is not sorted. Okay? And then you can see, how in some cases you will miss a value. The value is in the array, but because the algorithm assumes the array is sorted and it is not, then you cannot find the value anymore. So those would be useful exercises to go through, just to see what the algorithm will do when the assumptions are not there to begin with. Okay. Any other questions? Yep.
On the binary search algorithm, in line 10, it's in model 60. After you explain the logic of assigning m plus 1 to b and m minus 1 to e, you say, repeat this until b is greater than e, which means that the initial value is greater than the last value.
Correct.
Is that possible, Rob, since it's
Yes.
sorted?
Yeah. Well, we did a few traces like that when we talked about binary search. So let me see if I can. Nope. The other one. Okay, I think it is probably in this file because I put the files when into the topic when we talk about the topic. So let's see if this is one of those. Because I remember we traced the binary search algorithm in the class. Did I? Okay. How did I did? It's not on the 11th, so it's on on another day. But they will cross over, because if they don't cross over, then we have a problem. If you're trying to find a value that does not exist in the array, b eventually will be greater than e, which is a flag to tell you you can exit the loop now, because the value you're looking for is guaranteed not to be in the array.
Okay, so the increment is, it runs over the value. So once you keep adding one, you keep checking, and you miss the value, you run over it.
You're not just adding one, because what you're adding one to m.
Yeah.
In other words, within the range of the array that can contain the value or potentially contain the value that you're looking for, m is the middle part of that. And you're adding 1 to m when you update b, you're subtracting 1 from m when you are updating e. So they will get closer and closer together, but not only that, they're also getting closer and closer together in a way that they will cross over if the value that you're looking for is not in the array. I'm guessing it is in the file, maybe on the 13th. Yeah, I think I looked in the wrong place. It's either the 13th or the 18th. So look into those two zip files. It should be there. I think we traced that. Okay. I'm fairly sure that we did. I would not. I wouldn't do it without the trace. Bad linear search. Okay, so that's must be the 18th. Is it?
I think so.
Okay. Just going to open up the file binary search ODS. And I think it has enough test cases to illustrate both the case when we can find the element and also the case when we cannot find the element. Well, this is also showing you, when you study for the test, don't just read the modules, which are fairly static. Go back to the examples that we went through in the class. Okay, all the traces that we have done, all the files that I have uploaded, all of those are a part of the class's material. The video clips, for the most part is there. I might have missed, like once or twice, but for the most part it is there. And in this case, 9 is not in the array. If you look at the way B and E are updated, let me just show the header part here so we can keep an eye on B and E. Initially, B is 0 and E is 7, right? And then B gets updated to 4. E also gets updated to 4. And in this case, I think the array does have the element. Oh, okay, it does have the element of 9, so that's why it exited. And we never talked about how it can exit without finding the actual value. What? Yeah, but did I demonstrate it with one test case like that?
Is that where we short-circuited?
I kind of vaguely remember that, but it's not here. Okay, well, so I'll just go ahead and do it. That's not a big deal. I will go ahead and do it.
Because I remember you said to switch them, so you make one false first, so you don't have to check the other condition.
I said that, but I cannot remember whether we actually, went through a test case like that. Yeah. So I'm going to do it now. Okay. Instead of looking for 9, I'm going to look for 5. 5 does not exist in the array, and obviously, a good chunk of this trace, has to be removed, so then we can start from scratch. I will do this. Look at the code on one side, look at the trace on the other side. Okay. All right, so this is a good, revisit or a good review of arrays as well as the binary search algorithm. I thought I did it, but I did not. Okay, so line 1 is initializing B to 0. Line 2 is initializing E to bar A bar minus 1. We need to look at the entire size of A in this case. It has 8 elements. So bar A bar is 8, 8 minus 1 is 7. E starts with a value of 7. Are we okay so far? This part is the same as last time, because we have not gotten into the loop yet. Line 4 is going to calculate the value of M. M is the floor of B plus E divided by 2. B is 0, E is 7. 0 plus 7 is 7. 7 divided by 2 is 3.5. The floor of 3.5 is 3. Then we go to line 5. Line 5 is comparing A bracket M or A bracket 3 with K. A bracket 3 has a value of 7. K has a value of 5. 7 is less than 5 is false. Okay? So we have to go to line 7. So let me just write here. A bracket M is less than K is false. We move on to line 7. And line 7 is asking, is K less than A bracket M? A bracket M has a value of 7, K has a value of 5, K is less than A bracket M is true. Are we okay so far? Then we move on to line 8. Line 8 in this case will update E. E becomes M minus 1. M has a value of 3, 3 minus 1 is 2. So E will update to 2 at this point. After line 8, we are done with the conditional statement. We jump all the way to line 10, which is the end of the conditional statement, the end of the post-checking loop. The post-checking loop checks for 2 conditions. A bracket M equals K is false, because 5 does not equal to 7. But since this is a disjunction, I have to check the second condition when the first one is false.